Electroactive materials. Electroactive materials can be of different types. Here we're talking only about electroactive polymers. أكيد في غير البوليمرز بس هون نحنا بس بدنا نحكي عن electroactive polymers. So electroactive polymers, abbreviated by EAP, are polymers that are able to change their shape under electrical stimulation. So again, these are properties changing materials that change their shape based on electricity, يعني electric stimulation or electric stimulus. So for example, we apply a certain voltage to these electroactive polymers and then they will change their shape. The most common applications of this type of material are in actuators and sensors. شو هن actuators and sensors? In fact actuators هن ال tools اللي بقلب ال devices يعني هن بيعملوا action. They make a certain action. As in this figure, we'll see in detail what we have here. A typical characteristic property of an electroactive polymer is that they will undergo a large amount of deformation while sustaining large forces. يعني they can be deformed a lot, but they can at the same time sustain large forces. يعني they can withstand large forces. بيتحملوا forces كتير عاليين وبيعملوا بنفس الوقت deformation كبيرة. In this image we see an electroactive gripping device كماشة. Okay, that is made of an electroactive polymer. By applying a certain voltage to this electroactive material, so it will undergo a certain change in its shape. It will change its shape. بتشوفوا انه كانت الكماشة مسكرة. Now the gripper is open. So in configuration A, for example, it can hold a ball here أو هي كانت ما في عليها شي. In configuration B قادرة هي تفلت a ball. يعني إذا كان بالA لنفترض كمشت ball, قادرة بالB it can release this ball. Just يعني simply by applying a certain voltage on its fingers. In C we can see that if once we remove the voltage that we applied in B, once we remove this voltage, the device will go back to its initial state. يعني راح تشيل الديفورميشن يلي كانت عاملته. okay, so قلنا انه it can undergo a large amount of deformation. عم تعمل deformation كتير كبيرة. We can clearly see this deformation while sustaining large forces. يعني this ball can have a good mass. The majority in fact of historic actuators, هل هيدا بنسميها الجريبر بنسميها actuator لأنه it can make a certain action. For example, gripping a ball or releasing the ball. But the majority of historic actuators are made of ceramic piezoelectric materials. In the history, in fact, actuators were mainly made from ceramic piezoelectric materials. But the disadvantage of the use of these piezoelectric materials is that they are able to make a fraction of a percent of deformation. يعني a very very small deformation. In the late 1990s, some electroactive polymers were discovered and they could exhibit up to a 380% strain. قادرين يتحملوا كتير 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 strain. يعني قادرين يعملوا كتير كتير deformation. يعني قادرين يعملوا deformation بالشكل اللي نحنا بدنا اياه. So they are much more flexible, which is much more than any ceramic actuator, and so they replaced the ceramic piezoelectric materials for actuators with electroactive polymers. لقوا انه electroactive polymers are more beneficial as actuators than ceramic piezoelectric materials لأنه قادرين يعملوا deformation أكتر. يعني هن مهمين للapplications اللي نحن بدنا إياهم بشكل أفضل. Where do we use such type of actuators? In fact, one of the most common applications of electroactive polymers is in the field of robotics and the development of artificial muscles. Thus, an electroactive polymer is often referred to as an artificial muscle. So we can consider that this gripper is like an artificial muscle. قادر هو يمسك ويفلت ماس. كمان فينا نستعمله in other applications in robotics. وبعدين in robotics we can have inspiration in the field of architecture, for example. Their ability to emulate the operation of biological muscles with high fracture toughness. They are very very tough. يعني they are ductile also أكيد. Because they are tough يعني they are ductile يعني they are not brittle. We're talking about here polymers. مش عم نحكي عن ceramics كانوا هن brittle بينما polymers are not brittle. They have a large actuation strain and inherent vibration damping. Vibration damping يعني they can reduce the vibrations. إذا في اهتزازات هن قادرين يخففوا من هالاهتزازات لحتى ما يأثروا على بقية مثلا إذا في عنا electric devices بيتأثروا بالvibrations so قادرين هن يمتصوا هالvibrations ويخفضوها. So due to all of these properties the scientists were يعني fascinated with the electroactive polymers and they started to think where we can use them. بلشوا يقولوا انه فينا نستعملهم كartificial muscle بالروبوتكس. فينا نرجع نستلهم من هيدي الابليكيشن بمحلات تانية. Electroactive materials can be easily manufactured into various shapes. So we can give them the shape that we want with ease. Due to their ease in processing many polymeric materials, making them very versatile materials. In the short term, electrically deformable, large surface forming components could be made from electroactive films to produce various textures in wall coverings or wallpapers. In the field of architecture, electroactive polymers يعني have not yet been widely used, but we can in the short term use these electroactive polymers to produce various textures in wall coverings or wallpapers. نقدر نستعملهم بالwall coverings بالwallpapers بيساعدونا بهيدا المجالات. And so we can be inspired of the use of electroactive polymers in different applications in architecture. So now we will continue with color and optically changing smart materials, and particularly the electrochromic smart materials that change their color based on electrical stimulus. So electrochromism is the change of the optical transmittance or absorbance of a material under an applied voltage. So these materials change their colors, and the color depends on يعني which frequencies the material transmit and which frequencies of light the material absorb. So the color in fact هو له علاقة بال transmittance and absorbance of the material. أي ألوان الجسم عم يمتص وأي ألوان الجسم عم بيمرر وأي ألوان الجسم عم يعمل لهم reflection. اوكي هيدا الcolor بتأثر بهدول الشغلات. So when we say that the material changes its color يعني its optical properties like transmittance and absorbance are being changed. These transmittance and absorbance properties in electrochromic materials change once we apply a voltage. يعني لما بنحط عليه كهرباء، لما بنوصله على كهرباء when we apply an electrical power. For example, electrochromics are materials so they change their color in response to an electrical stimulus. The color can change between a transparent, like in this case, bleach state, and a colored state, or between two colored states. So in this image we can see that if we apply a tension of, or a voltage of minus 0.2 volts, this electrochromic material is transparent. If we apply the inverse voltage, and if we apply plus 0.2 volts, this material will look like green. غير transmittance والabsorbance تبعيته once we change the applied voltage. An electrochromic material that changes into several colors is termed as polyelectrochromic. Here we can see that the same material can have different colors, so it's more than an electrochromic material, it's a polyelectrochromic material, يعني polycolors. Electrochromics are either organic or inorganic materials. They can be both organic or inorganic. In electrochromic materials, the absorbance and transmittance can be changed or controlled automatically or manually. يعني ممكن الماتيريال بحد ذاته هو غير منه لحاله الابزوربنس والترانسميتنس، ممكن هالشي يكون user driven. Electrochromic materials provide great opportunities for a variety of energy saving and color tuning applications, including يعني وين بنلاقي هالelectrochromic materials. We see them in smart windows, in multicolor bistable displays بألوان مختلفة بالدisplays to control the flow of light. The darker the color of the electrochromic material, so less flow of light will pass. We see electrochromic materials in anti-glare car rear view mirrors بالسيارات, in smart sunglasses, and in aircraft windows. يعني we see them in our everyday life. Now, where do we see electrochromics in architecture, or what is the importance of electrochromic materials in architecture? Electrochromic, smart or dynamic glass is an electronically tintable glass. Tintable يعني it can have different tints, it can have different colors. It's an electronically tintable glass used for windows, skylights, facades, and curtain walls. The advantages of electrochromics. So as we have said, it can improve the occupant comfort because it provides at the same time both and shadows. It can allow the access of daylight, and it allows also outdoor views. It maximizes the occupant comfort. It reduces energy costs. We don't want to turn on lights inside because we have the daylight. بيقدر يفوت ضوء الشمس لجوا using this electrochromic glass. Other advantages of electrochromics are reducing design costs by minimizing and eliminating the need for shading devices. We don't need curtains anymore, and this will reduce the design costs. It's built in, everything is in this smart glass. It also provides architects and designers more design freedom and less restrictions. So architects and designers will be more free in their designs. There will be less constraints, less restrictions. And electrochromics add an always changing facade depending on the color, opacity and reflectance of the glass. يعني the facade will look in different colors. It will look in different opacity. Sometimes it's transparent, other times it's opaque, other times it's very dark. مثلا it's blue, it could be I don't know, green. It can change its color. أكيد حسب نحنا شو عم نستعمل كإلكترونيك electrochromic material. Other advantages of electrochromics in architecture. Electrochromic materials can be used both internally and externally. So internally it provides both transparency and privacy as we can see here. هون مثلا بدنا اياه شوي انه يخلي العالم تشوف شو عم بيصير جوا. So we can control the optical properties. We can control the color by making this glass transparent. And if we want to have a privacy inside, we can turn this glass to a dark color. Externally it provides sun exposure and protections, as we can clearly see in this image in Morehouse, in a restaurant in Washington. So here we can see one side is tinted and the other side is clear, depending on our choice.